Okay, a continuation of chapter 8, and this is kind of the conclusion where we're going to be using concepts from 8.1, 8.2, and 8.3. Just kind of making sure that you understand the concepts and the skills in a little more in depth. This sheet should be in Canvas, so you should have printed it off so you can follow along with me. On number 1, it says a confidence interval for a population mean has the length of 139.4. Find the margin of error. Now, I want to explain this by showing a small demonstration for you guys. If we're talking about the length of the interval, that would be from one number to the next. So to speak, let's say if our confidence interval was from 10 to 20. And that's what we wrote as our confidence interval, from 10 to 20. Now, to understand the length, I'm actually saying that from this point to this point, my entire length is 139.4. Now, this is not actuality. The actuality of this length, let me do that so that won't confuse anybody. The actuality of this length would be 10. Okay? From 10 to 20, you would say that length of numbers would be 10. So in order for me to get 10 and to get 20, whatever was in the middle would be your mean, okay? You had to add something to that number to get your 20, and you had to subtract something to get your 10. So in order to find that margin of error, your margin of error would be what you added this way would be the same number you subtracted to the left. So that means that if I give you the length, then the margin of error has to be half of it. That should make sense. For this particular one, my error should be 5 numbers. I should be going 5 numbers to get to 20 and 5 numbers to get to 10. So that's based upon the fact that from 10 to 20, the entire length, the distance of it is 10 numbers. So to find out what I had to add and subtract both ways, I divided in half, because that's where your mean sits, is in the middle. Okay? It's in the middle of your actual beginning number for your confidence interval, which would be here, and your ending number in your confidence interval. So this is just an example of what I was asking you to give me. So the problem gives you the number of 139.4. So in order to find the margin of error, I would just simply divide by 2. Because the length of from one number to the other number is 139.4. So if I divide it by 2, you get what you had to do on both sides, which would give us our 69.7. And we write that as big E, because big E stands for error, as 69.7. Okay. Now the second one says a confidence interval for a population mean has a margin of error of 10.7. Now I want you to obtain the length of the whole confidence interval. So if I know that my error is 10.7, then that means that you add 10.7 to the right side and you subtract 10.7 to the left side. So if I want to know the whole length of my interval, I would simply add 10.7 twice, or multiply it times 2. That would give us a length of 21.4. Okay. Number 3, it says, suppose you plan to apply the one mean z interval procedure to obtain a 90% confidence interval for a population mean. You know that that symbol means population population standard deviation is 12, and that you're going to use a sample size of 9. Your question is slightly different. I want you to find the margin of error. I don't want you to find the whole confidence interval. I just want to know the error. Now, I didn't give on the previous videos an actual error formula. But if you wanted to see the formula, we were doing the error on the right side of that plus or minus sign for our formula. Let me write here at the top. The confidence interval formula says take that sample mean plus or minus your z-score times the population standard deviation divided by the square root of n. Now, when we were working this side, when we did our division and we multiplied the two numbers together, that's what we said was our error. So the actual formula is that side, okay? So you can write it as big E equals that z-score times the population standard deviation divided by the square root of n. That would be your official formula for error, margin of error. So we're going to plug in our numbers. Now, knowing that this is population standard deviation and we're dealing with 90%, we're going to pull up our chart, and I'm going to pull it up. So this one, this is our chart, and we're using our box because we know our population standard deviation. It gives you that symbol. This symbol represents population standard deviation. Okay, so our problem, and I'm going to go back to make sure I got the right percentage, is 90%. So your sheet should still be labeled, but we know 90% represents that second number. So that z-score would be 1.645. Times the population standard deviation is 12 divided by the square root of n, which will be our sample size of 9. So we're going to say 12 divided by the square root of 9, which is 3, will give us a 4. So you're going to take 1.645 and multiply it times 4. And that would give 6.58. And it says here around 2 decimal places. So it gave me 2 decimal places exactly. So our error that we would be adding and subtracting on both sides of the mean would be 6.58. Okay, let's look at another problem. All right, our next example, a problem, it says we have a sample of 712 federally sentenced adult male prisoners had an average sentence of 9.15 years. Assume that for federally sentenced adult male prisoners, the population standard deviation of sentence length is 17.2 years. Now, A says determine the sample size required to have a margin of error of 5.5 years and a 90% confidence interval. Now, finding sample size is something we have not talked about. So I want to give you an example, and actually two, on how you would find the sample size dealing with confidence intervals. Now, that particular formula is sample size, is lowercase n, equals the z-score times our population standard deviation divided by your margin of error. Okay, so we're going to plug in that information. Now, if we're dealing with 90%, and we know it says population standard deviation, we're going to be using our little box. So 90%, we know still here, I have it still circled, is 1.645. That would be our 90%. So we have 1.645 times the population standard deviation is 17.2 divided by, I said the margin of error is 0.5. So we're going to multiply and then divide. So 1.645 times 17.2 would give you 28.294. Divided by 0.5. And you would get 56.588. Now, I left very important thing off of the formula. Oh my goodness. All of this is squared, okay? So we've worked inside. Now, you must square that number, okay? Square that number. So when you hit the square button on your calculator, we get n to equal 3202.201744. Now, this is the golden rule for sample size. Sample size is going to, if this is a decimal, and you can kind of think of it like people. You wouldn't have decimal of people. So sample size, you will always round up, and I'm talking about whole number. Let me write that. Okay, so I'm talking about this number here. That's your whole number. So you're always going to round up. So that would give us our n, our sample size, being 3,203. I don't look at it 2 is smaller than 5. It stays at 2. None of that. This is the rule. You always round up one whole number. So that last number before the decimal will go up 1. So that gives us 3,203 as our sample size. Let's look at part B. It wants you to find a sample size that is required to have a margin of error of 0.5 again. That's our margin of error. But this time we're doing a confidence interval of 99%. So we're still using that population standard deviation of 17.2. So we're going to take our formula, which says we're going to take our z-score times the population standard deviation divided by the error, and we're going to square it. And so we're going to go to our table, and 99% we know would be that last number, 2.576. Times 17.2 divided by our error of 0.5. So 2.576 times 17.2 give you, I'm just writing everything for you guys, 44.3072 that we're going to divide by 0.5. Divide by 0.5, and you should get 88.6144, and we're going to square that number, and I'm going to write it over here. You get 7852.511887, and none of that matters because the rule says we will always round up that one decimal. So our N, our sample size, would be 7,853. And that would conclude everything you would need for Chapter 8 on confidence intervals.